Hello, welcome to Engineer's Mindset. Now, I'm going to show you how to derive the equation for work done in a polytropic process. Now, recall that we said the polytropic process is given as PV to the power of n is equal to constant. So, this condition simply implies that P1 V1 to the power of n is actually equal to P2 V2 to the power of n is also equal to P V to the power of n. That's what the equation stands for. Okay, so this simply means that, so let's call this equation 1. So this simply means that P1 V1 to the power of n is actually equal to PV to the power of n. Also, P2 V2 to the power of n is also equal to PV to the power of n. So let's work one-sided. Let's work with P1 V1 to the power of n equals PV to the power of n. You can try to try the other side, it's still going to give you the same result. Okay, so if P1 V1 to the power of n is equal to PV to the power of n, it means I can make the subject of the formula. That means P is equal to P1 V1 to the power of n all over V to the power of n. So this becomes my pressure. Now recall that work done is actually an integral from V1 to V2 of P dV. So we're able to obtain the value of the pressure, which is P, as this. So in place of pressure, we simply would substitute this value for pressure. So we're going to have that work done is now equal to integral from V1 to V2. In place of pressure, we have P1 V1 to the power of n all over V to the power of n times change in pressure to V. Okay? So, as usual, P1 represents the condition of pressure at stage 1, V1 represents the condition of volume at stage 1. So, which means they actually have values, they are constants. So, whenever you're integrating, always bring that constant out of the integral sign. So, P1 V1 are all constants, so we can come out. So, we have P1 V1 integral from V1 V2, we have V all over V to the power of n. Okay, now by indices, recall, if I have 1 over x, this is same as saying x to the power of minus 1. So which means 1 over V to the power of n is the same as saying V to the power of minus n. Okay, so I can now write that equation as work done is equal to P1 V1 to the power of n integral from V1 to V2. In place of the V over V to the power of n, I can simply change to V to the power of minus n dV. Okay, so I can now integrate. Okay, so this is now equal to P1 V1. If I integrate V to the power of minus n, by the rule of integration simply says add 1 to the power divided by the power plus the 1 we added. So we have simply V to the power of minus n and 1 to it plus 1. So minus n plus 1 divided by the power, which is minus n plus the 1 you added plus 1. Okay? All into putting my limits is V1 to V2. So I have that. So work done is equal to P1 V1 to the power of n into, I can now write this equation as V to the power of 1 minus n all over 1 minus n. So V1 to V2. Okay, so just a change of the order. So minus n plus 1 is same as 1 minus n, which is here, and then 1 V minus n. Okay, so let's pull out 1 minus n out of the integral. Let's pull this out. We are simply going to have our work done is equal to, this becomes P1 V1 to the power of n all over 1 minus n. So just pull 1 minus n out to have that. So you're left with V to the power of 1 minus n into V1 to V2. So we can now, okay, now we're now putting the limits of integration. Upper limits minus lower limits. Okay, so we are going to have that work done is equal to P V to the power of n, P1 V1 to the power of n, all over 1 minus n into, we put in the limit of integration, upper limit is V2. So we have V2 raised to the power 1 minus n, okay, minus lower limit is V1 to the power of 1 minus n. So you have this. Okay, so work done is now equal to P1 V1 to the power of n over 1 minus n is now equal to. Now from indices, please take note that I can actually break this from indices. Okay, let me just explain them. Now from the law of indices, recall that if I have x times a, x to the power of a times x to the power of b, the law says that once two variables have the same, once two numbers have the same base and it's raised to different power, simply pick one of the base and add the power. So I have a plus b. Also, if I have x times a multiplied by x minus b, it's also the same thing. Two variables or two numbers having the same base here is equal to x, and then having different powers. All you do is pick one of the base and add the powers. So I will simply have here a, in this case now, the power of x is minus b, so you simply have a minus b. Okay, so that means that if I have x, it means now that x raised to the power a minus b can be broken down to simply what? X to the power of a times x to the power of minus b. Okay, so this can actually be broken down to this. So it also means now that if I have v2 raised to the power 1 minus n, it means that v2 to the power of 1 minus n can be written as simply v2 to the power of 1 times v2 to the power of minus n. This can also be written as is from indices. It also means that for v1, it can also be v1 to the power of 1 times v1 to the power of minus n. So having noted that, we are now going to have that this is now going to give us v2 to the power of 1 times v2 to the power of minus n minus v1 to the power of 1 times v1 to the power of minus n. So you close your brackets. Okay, so let's now expand this bracket with p1 v1 to the power of n. Let's expand this bracket and see what we're going to have. We'll get that work done is equal to, this will give us p1 v1 to the power of n times v2 to the power of 1 times v2 to the power of minus n minus p1 v1 multiplied by this. This means p1 v1n times v1 to the power of 1 times v1 to the power of minus n all over 1 minus n. So I have this. Okay, so work done is now equal to, please take note. Take note, we said earlier from equation 1. Recall from equation 1 we said p1 v1 to the power of n is equal to p2 v2 to the power of n. So which means if I compare this equation, I'm going to see p1 v1 to the power of n. In place of p1 v1 to the power of n, I will simply replace with what? p2 v2 to the power of n, because so that this was the condition that was made to us on the polytropic process. So from equation 1, p1 v1 to the power of n is simply p2 v2 to the power of n. So in place of p1 v1 here, we simply replace with p2 v2, just so that everything here can be what in terms of what condition as v2, because you have v2 and you have v2 here. Meanwhile, for this case, you have p1 v1, you have v1 v1. So everything here signifies condition as state 1. So just to make everything here to be at condition of state 2, you now record the equation from 1 that p1 v1 to the power of n is equal to p2 v2 to the power of n. So in place of p1 v1 to the power of n, we simply replace it with p2 v2 to the power of n. So we are going to have that work is equal to, so in place of this, we have p2 v2 to the power of n times v2 to the power of 1 times v2 to the power of minus n minus p1 v1 to the power of n times v1 to the power of 1 times v1 to the power of minus n all over 1 minus n. Okay, so at this point, work done is now equal to, let's collect like this. We are going to have p2 V2, let's bring P2 and V2 together. P2, V2 to the power of 1, then relate V2 to the power of n and V2 to the power of minus n together. We have, since they have the same base, we can simply have V2 to the power of n times V2 to the power of minus n. Okay, minus. Do the same thing for the other side. You have P1, V1 to the power of 1 times V1 to the power of n times V1 to the power of minus n, all over 1 minus n. Okay, so you're simply going to have that work done is now equal to, so of course, v to the power of 1 is same as v. So this will give us P2, V2. Okay, this will give us P2, V2. Then, from the law of indices as well, two bases having the same, or two numbers having the same base, pick one of the base and add their powers. So I pick one of the V2 and then I add the power. So I have V2 to the power of n minus P1, V1, P1 to the power of n minus n, all over 1 minus n. Okay, so work done is now equal to, this gives me P2, V2, n minus n is 0, so I simply have V2 to the power of 0 minus P1, V1, V1, n minus n is also 0, so I simply have 0, all over 1 minus n. So as usual, whenever a variable is raised to the power 0, it's simply 1. So I simply have that. This implies that work done is now equal to P2, V2 minus P1, V1, all over 1 minus n. Okay, so that's it. Alright guys, that's how to derive the work done in the polytropic process. I hope you find this very interesting, and of course, share your comments or your thoughts. Ask any question in the comment section. I always respond to all your questions. In the meantime, subscribe, like, and of course share the videos for more subscribers. I will see you in the next video. Thanks and cheers.